Question 1. In this question, we know that gx equals to 2 when x is less than 0 and equals to 0 when x is ranging from 0 to 1 and is minus x plus 1 when x is ranging from 1 to 2 and is minus 1 when x is bigger than 2. So we can just figure out the picture of the y equals to gx should be look like this. This should be 2, this should be minus 1. And here we know that this should be 1, this should be 2. And that is the picture of y equals to gx. Concerning the picture, we know that y is ranging from minus 1 to 2. So we can easily figure out the distribution of y equals to 0 when y is less than y and equals to 1 when y is bigger than 2. That is the meaning of distribution function. And now for y ranging from minus 1 to 2, we should know that when y equals to minus 1, the probability that y equals to minus 1, x actually equals to the probability that x is more than 2 and should be 1 minus the probability that x is less than 2 and should be 1 minus fx2. That's the definition of the distribution function 2. And when y equals to 0, the probability that y equals to 0 should be the probability that x is ranging from 0 to 1 and should be fx1 minus fx0. And when y equals to 2, the probability that y equals 2 actually equals to the probability that x is less than 0 should be fx0. And when y is ranging from minus 1 to 0, the distribution function of y should be the probability that y less than y and should be the probability that minus x plus 1 less than y. Then should be the probability that x is more than 1 minus 1 should be 1 minus the probability that x is less than 1 minus y and should be 1 minus fx1 minus 1. And that's some probability we should know. Then when y is ranging from 0 to minus 1, we have the equation of the density function fy equals to fxx divided by g derivative at the absolute value when x is equals to 1 minus y and should be fx1 minus 1. Now we can figure out both the density function and the distribution function of y. The density function fy should be in the form of this. It should be 1 minus fx2 when y equals to minus 1 and should be fx1 minus 1 when y is ranging from minus 1 to 0 and should be fx1 minus fx0 when y equals to 0 and should be fx0 when y equals to 2 and should be 0 in the other conditions. Now given by the definition of the distribution function fyy equals to the integral from minus infinity to y, the density function of y dy, we can easily figure out the distribution of fy should be in the form like this. It should be 0 when y is less than 1 and should be 1 y greater than 2. That's we have definited in the beginning. And then in the middle we have that 1 minus fx minus 1 when y is ranging from minus 1 to 0 and should be 1 minus fx0 when y is ranging from 0 to 2. And that's the answer of the first question. That's all. Thanks.